A Scientific Revolution, Part 2, Illusions of Light by Francis Watts. Quote, "Everything's fine today. That is our illusion." And that is by Voltaire. According to theoretical physics and the concept of particle wave duality, sometimes light is observed to be a particle. When it is observed to be a particle, that's because that's what light is. While observations of light waves are illusions, observations of light particles are real. Rarely is it discussed in detail the times light is observed to be a particle, despite all that had been explained in terms of waves in the 19th century, and despite the simplicity of that explanation and the technology based upon it. There were 3 experiments that had taken place over those same years, which, we are told, could not be explained in terms of light waves. They are as follows: the ultraviolet catastrophe, the photoelectric effect, and the Michelson-Morley experiment. They were all performed during the 19th century classical period, but not explained until the beginning of the 20th century by Albert Einstein. He explained them all in terms of particles instead of waves. The first experiment is called a catastrophe because it was the first crack in the theory that light is a wave. It was a catastrophe because what is observed in this experiment cannot be explained in terms of waves. The nature of this catastrophe is referred to as ultraviolet because it is about what happens in the ultraviolet with light in the ultraviolet range. Expectations were based upon the wave theory of light, but something else happened. Years later, Albert Einstein was able to explain what actually happens. He did so using particles and not waves. Heat creates light. In these experiments, different metals were heated to the point at which they emit light. You can do it yourself just by making a wood fire and sticking by sticking an iron poker into it. When the end of the poker gets hot enough, it will begin to glow light. These experiments, however, took temperatures far higher than possible with a basic wood fire. At first, metals glow a dim red light, but as those metals got hotter and hotter, the light gets brighter and brighter, and its color shifts from red to blue and even violet. From these observations, 2 physicists developed an equation that expressed the relationship between the heat of the metal and the brightness and wavelength of the light emitted. It worked great at lower temperatures. At higher temperatures, the ultraviolet range, it stopped working. What was predicted to take place with ultraviolet light, according to this equation, is not what actually happens. This failure to predict with an equation is what is considered the catastrophe. It is not an observation of light itself. It is the observation that there is a difference between the prediction of a mathematical equation and what actually takes place. The prediction from this early mathematical equation gets mentioned when the story of this catastrophe gets told, but little attention is paid to it. According to the equation, when increasing heat into the ultraviolet range, the intensity of light was predicted to go to infinity. Now, without looking at any equations and just using your own common sense, is the brightness of light created by heating metal going to infinity something that makes sense? This prediction doesn't make intuitive sense, and it violates a a fundamental law of classical physics, the conservation of mass and energy. For light to increase to infinity, as the equation predicts, this basic law is broken. This failure of an equation is called a catastrophe, but had the equation been correct, basic laws of physics would have been broken. To me, that would have been the real catastrophe. Galileo derived an equation for how objects fall to Earth, but drop something from high enough and that equation stops working. Newton derived equations for planetary motion that were good enough to get us to the moon and back. But for the larger universe, you need Einstein's equations, and even those only work within some limited range. The reasons are different for why all these fundamental equations stop working in a certain range, but none of those reasons cause us to abandon the theories they support. Observing that the equation that causes the catastrophe only works within a limited range is observing that it works like all scientific equations work. That doesn't sound like a catastrophe to me. Max Planck later came up with a new equation which worked. However, for it to work, an assumption had to be made about light, that it is quantized. It comes in individual packets. Planck drew no new larger conclusions from this. It was Einstein who said that this quantization is an observation of light as a particle. Particles are quantized. That's what makes them particles. Therefore, light is a particle. This makes sense, but here is the thing. Waves can also be considered quantized as well. We may think of an ocean wave that surfers ride as something continuous, but that is only in the direction perpendicular to motion. In the direction of motion, waves are discrete. An ocean wave crashes with force against the shore. The ocean retreats, and then the next wave comes. Think about sound waves. Beats are heard individually, but play them quickly enough, and you begin to hear a tone of sound rather than beats. Sound appears continuous, but only because the space between the waves are so small. The force all waves carry can also be considered quantized. The quantization of light is like the motion of light. It can be explained by particles or waves. Just because Einstein explained the quantize of light in terms of particles, that doesn't mean light is a particle. The second significant observation explained by Albert Einstein, the photoelectric effect, was first observed in 19th century experiment, and then further experiments were designed with the purpose of not just observing, but measuring the effect. Back then, the photoelectric effect was understood in terms of light waves because that was their understanding of light. Similar to the catastrophe, this story is not about the effect itself, but some smaller detail about the effect, which turned out to be different from what everyone assumed should happen. It's called the photoelectric effect today because light is explained in terms of particles called photons, which then cause electrons to move. In the 19th century, the effect did not have a name. It was simply described in terms of what was observed. The effect that light has on the motion of electricity through empty space. Normally, electricity needs a closed loop for it to flow through wires. It's not like the water that flows through a hose and spews out at hose's end. But it can jump a small gap that might exist in an otherwise closed circuit. One way to get the electricity to jump the gap is to apply a voltage to one end of the circuit. Give it enough voltage and the electricity will jump. There are other ways to make it easier for electricity to jump the gap, and one way involves light. Its presence makes it easier for electricity to jump. This is something that all light does, apparently, but it's ultraviolet light that was studied in this experiment because it is ultraviolet light that has the greatest effect on the ability of electricity to jump the gap. Just as the ultraviolet catastrophe is about something unexpected that takes place relative to the intensity of ultraviolet light, so too is this story. In the experiment, it was expected that by increasing the intensity of the ultraviolet light, the speed at which the electricity jumped the gap would also increase. This is not what happened. Instead, the speed at which the electricity moved remained constant. It's not the observation of the photoelectric effect itself that cannot be explained by waves of light. It is only this constant speed of the electricity that was unexpected. Einstein came later and explained the constant speed in terms of particles. However, this observed constant speed of electricity is not like light's constant speed. It is only an upper limit that has been reached in the ultraviolet range. There is also a lower limit, a minimum speed at which electricity can be made to jump the gap. From here, the speed increases with increased light until it reaches the maximum speed in the ultraviolet range. The speed of sound was at one time thought to be a speed limit beyond which nothing physical could move. That was disproven when the speed of sound was broken mid-20th century. According to Einstein's theory today, the speed of light is also a speed limit, except for different reasons that some in recent years have claimed to have exceeded as well. If there are speed limits for all physical matter, what is so unusual in the observation that electricity has its own speed limit? Expected ahead of time or not, why should this very particular observation upend a wave understanding of light? The last experiment that Albert Einstein based his particle theory of light upon is perhaps the most well-known of the three. It's called the Michelson-Morley experiment, named after the experimental scientists who carried it out. Just as with the previous two experiments, what was expected to be observed in this one is not what was actually observed. Then, later, Einstein explained what was actually observed in terms of particles. Light as a wave needs a medium through which to move, just as all waves need mediums. Put a ringing bell in a sealed glass jar and you will still be able to hear it ringing. Attach a device that sucks out all the air inside the jar, a vacuum pump, and the bell will continue to ring, but you will not be able to hear it. Without the air through which sound waves move, sound doesn't move. When we look up into the night sky, we don't just see stars. We see light that has traversed the vast expanse of seemingly empty outer space. If light is a wave, outer space only appears empty because the light from distant stars only moves if there is a medium through which it can. The experiment was based upon the wave understanding, and designed to detect Earth's movement through the medium that fills the vastness of seemingly empty outer space. If Earth is moving through what fills outer space, we should be able to observe that motion in experiment. That's what this experiment was about, and it famously failed to detect that relative motion. At first, there was disagreement over what explained this failure. Then Albert Einstein explained it indirectly in terms of particles. The experiment failed to detect Earth's motion through the medium that fills outer space because no such medium exists. Light is not a wave through a medium. Light is a particle that moves through space, and that space can be empty or filled. Outer space is imagined to be filled if light is a wave, but if light is a particle, then there is no reason to imagine outer space as filled. On the surface, this makes sense, but the details of this story are glossed over. The experiment failed to detect a predicted amount of relative motion. It did not actually fail to detect all motion. Some motion was observed, just a lot less than predicted. If no medium exists, how could any motion be observed? These results were explained away as errors in measurement within a margin of error. Observations were not the observations were not explained to be verifications of a medium filling outer space. Some motion may have been observed, but that motion was illusionary because outer space is an empty vacuum. Not everyone agreed with this explanation. Much debate occurred over it, and other possible explanations were also put forward. Morley himself put forth the most simple explanation. The medium in outer space through which light moves is not stationary in space, but moving with the Earth. The medium and the Earth are moving together. In this alternate explanation, why the experiment observed no significant relative motion is because there is no significant relative motion between the two, but it is not because no medium exists. People think this famous experiment has no other explanation beyond Einstein's, but this very simple alternative also exists. It does not remove a medium filling outer space, and it does not undermine the wave explanation of light, but it does explain why the experiment failed. While it was Michelson and Morley who first performed this experiment, they were not the last. Several tried to replicate this experiment. Perhaps the most significant was that of Dayton Miller. He was a prestigious American physicist at the time, who today is never mentioned. He never believed Einstein's explanation. He thought the error made by Michelson and Morley was that the experiment was carried out at too low an altitude. The experiment was performed in a basement at the University of Cleveland, Ohio, an elevation of around 600 feet above sea level. Dayton Miller took the exact same scientific equipment and used by Michelson and Morley up to Mount Wilson in California, which is over 5,700 feet above sea level. The same experiments were made with the same exact equipment, with a difference of elevation of over 5,000 feet. Dayton Miller claimed to have observed the relative motion he was looking for. It was more than what had been observed by Michelson Morley, but it was still very small relative to the original expected speed. Just as the results of the Michelson Morley experiment was explained away As errors, so too were the results of Dayton Miller's work. Our belief that outer space is a vacuum isn't just based upon Albert Einstein's explanation of the Michelson Morley experiment, it is also based upon the belief that Dayton Miller did the exact same experiment at a higher altitude wrong. Particle wave duality states that sometimes light is observed to be a particle, but the ways in which light is actually observed to be a particle are never discussed. These are the primary ways, these three experiments, and the unexpected results that took place within them. Because the brightness of light created by the heating of metal doesn't go to infinity, because light can accelerate electron particles only so fast, and because Earth's motion through a medium is much less than expected. Light is a particle and not a wave. After Einstein explained these three experiments in terms of particles, the particle theory became popular again. But no new observations took place to support the theory for over 2 decades. A few experiments were made using X rays, which is light of a wavelength above ultraviolet light. These are said to also be observations that demonstrate light as a particle. The big observation, however, that needed overcoming was all the observations of light that had already been explained in terms of waves in the 19th century. If light is a particle, what explains how light moves through itself? If light is a particle, what explains the color of light? If light is a particle, what explains the constant speed of light? If light is a particle, what explains the interference patterns light makes? If light is a particle, then how do heat and light create each other? If light is a particle, how do our light bulbs and wireless technology work? These were all observations that before Einstein were given simple intuitive wave explanations. If light isn't a wave, then how are these observations explained? Particle wave duality is a concept invented for this purpose. It explains why observations of light can be explained in terms of waves, even though light is not a wave. It is like the power of a magic wand. With a single motion, all the observations that tell us light is a wave are turned into illusions. Any observation you can think of that might say light is a wave, nope. That observation is explained by the concept of particle wave duality. It is part of the illusion. Further, experiments were made not to observe light as a particle, but the nature of particle wave duality itself. The most well known of these experiments is called the double slit experiment. While it has the same name as the 19th century experiment upon which the wave theory is based, in most ways it is a completely unrelated experiment. There are two slits. That is the only similarity. In the 19th century experiment, a candle is used to create light. In the 20th century experiment, an electron gun is used to shoot electrons. In the 19th century experiment, patterns of light that we can all see for ourselves show up on a wall. It doesn't even matter what that wall is made of. In the 20th century experiment, a special surface has to be used that will record the impact of each individual electron shot out by the gun. Over time, there is a buildup of electrons. Over time, there is a buildup of electron impacts on this special surface that vaguely resembles the interference patterns light makes. It was thought that particles don't make interference patterns, but here is an experiment in which particles are making interference patterns. Because particles don't make interference patterns, these interference patterns made by particles demonstrate particle wave duality. It's not something that just light particles have, it's something that all particles have. And because light is a particle, it has the same property. To explain how particles behave like waves, in this experiment, more concepts and assumptions are required. Concepts required to explain how electron particles behave like waves makes absolutely no logical sense. They are absurd. No one denies the absurdity of of the concepts. No one denies the absurdity of the concepts used to explain this experiment. Theoretical physicists are quite proud of this absurdity. Most people are familiar with Schrodinger's cat experiment. It's not a real experiment, it is a thought experiment. Its purpose is to demonstrate the absurdity of particle wave duality. That is exactly why it is popular today, but for Carl Schrodinger, this absurdity is the reason why it is wrong. If assumptions lead to absurd conclusions, do you question the assumptions or just believe in the absurdity? Carl Schrodinger questioned the assumptions, but quantum theory today is based upon the absurdity. These experiments were not just performed to demonstrate particle wave duality, that all particles, regardless of whether they are physical or immaterial, have. Embedded within these experiments is a significant assumption that is not recognized by those who explain the results. This 20th century double slit experiment and others like it is based upon the assumption that light is a particle. It is because light is a particle that these experiments using electrons and other kinds of particles have anything to do with light in the first place. If light is a wave, these experiments made with particles are unrelated. It doesn't matter the explanation, it has nothing to do with light. With the exception of the Michelson-Morley experiment, all these other experiments and observations that demonstrate light is a particle that is sometimes observed to be a wave share something in common that is rarely pointed out when each one is individually discussed. This shared similarity, however, is significant. Each one of these experiments, even though very different from one another, all take place inside vacuums, volume of space where the air has been pulled out. The air has been removed from all of these experiments, and for the same basic reasons, can interfere with the motion of the electrons and light that move through it. Today, we understand spaces called vacuums to be empty of all physical matter, but that understanding is based upon the particle theory of light. If light is a wave, vacuums are filled with something physical. Just because you've removed the medium through which sound waves move doesn't mean that space is now empty. Put a ringing bell inside a glass jar. If you remove the air inside the jar, you will no longer be able to hear the bell ringing, but you will still be able to see the bell ringing. If light is a wave, this means the jar is not empty but filled with a physical medium through which waves of light move. The explanation for every one of these experiments performed in vacuums is dependent upon the belief that those vacuums are empty of all matter, but those vacuums are only empty of all matter if light is a particle. If light is a wave, then the opposite is true, and the explanations for every one of them is wrong, simply based upon this simple difference alone. In addition to Occam's razor, there's a second principle upon which I base my own method of rational thought upon. Carl Sagan eloquently put it, Extraordinary claims require extraordinary evidence. This makes sense, doesn't it? If someone wants you to believe in a story that sounds incredible, are you going to want you are going to want a lot of solid evidence before you accept it as true. The more crazy sounding a story, the more evidence required to accept that story. After all, Occam's razor is only about probabilities. The most simple explanation is not always and automatically the correct explanation. Sometimes it's possible that the more complicated explanation is the correct one. To accept such a claim, however, I'm going to need a lot of evidence because it is an extraordinary claim. The claim that light is a particle and that all particles have particle wave duality, which explains why light particles sometimes look like waves, is an extraordinary claim for basic reasons. The wave understanding at the end of the 19th century was built upon a solid foundation. It explained everything we see with our eyes and explained modern technology, and it did so in a simple way that did not involve inventing a single new concept. Then came these few experiments where some details of their results were unexpected. Based upon that, we've abandoned an understanding built upon a strong foundation. Based upon this new foundation, that light is a particle, our concepts built on concepts and complexity layered on complexity. The abandonment makes no logical sense to me. The evidence upon which the wave theory is based is far greater than the evidence upon which the particle theory is based. The abandonment makes no sense because we've traded a simple explanation for a complicated one. To claim that light is a particle is an extraordinary claim for another big reason. It is what broke physics in two. The evidence upon which the particle theory is based does not, to me, meet the standard of extraordinary. To meet the extraordinary claim. End of part 2.